Let's give a division of polynomials question a try. On this one, it's a little bit trickier looking polynomial for our dividend because we have x to the fourth, and then we skip our x to the third term, go straight to an x to the second. We skip our x to the first term, and we go straight to a constant. All right, there's no skipping over here in our divisor, dividing by x to the first and then a constant term. But we do have to be a little bit aware when we do skip powers of x. All right, it makes life easier if we include zeros as placeholders, basically. So as I set this up, I'm going to go ahead and we're using x to the fourth. We have 0x to the thirds minus 3x squareds, 0x to the first, plus 1 is our constant at the end. So notice I'm putting zeros as placeholders. That's really, really helpful as you're working through these types of problems if you skip powers of x. So to get started on this, with our long division, we want to always focus on the very first term here. So the x, and then the very first term in here, we're going to focus on the x to the fourth. And we say to ourselves, x multiplied by what is going to give us that x to the fourth? So x multiplied by x to the third should give us x to the fourth. Our next thing we're going to do is basically distribute that x cubed to each of these terms out in front. So first we have x cubed multiplied by x is going to give us that x to the fourth, just like we wanted. But then we also have to include x cubed multiplied by -1 makes -1 x to the third power. All right, as we're doing this, we're going to get nice columns. All right, we have an x to the fourth column, we have an x to the third column, and why we got that is because we kept our placeholders. That 0x cubed up above. So next, with long division, we subtract down, but that subtracting applies to both those terms we just listed. So we planned out the first part, x to the fourth minus x to the fourth is going to make 0x to the fourths. But then we have to be wary about the 0x cubes minus a negative x cube. All right, and I find writing these kind of horizontally next to each other is really helpful for students so they don't make the sign error along the way. All right, so 0x cubes minus a negative x cubed makes positive x cubed, which is going to go below. Next, we'll go ahead and bring our next term down. So minus 3x squareds come down, and we start again. All right, like renew the process. So we focus on x out in front, multiplied by what makes x cubed. So x times positive x squared is going to make that x cubed. And remember, this gets distributed to both the x and the -1. All right, so we already distributed it to the x, but now -1 times x squared makes negative x squared. And then we subtract down again vertically. We've already planned it out that x cubed minus x cubed is going to cancel itself out. We aren't going to have any more x cubes, but we do have to be a little bit careful when we have -3x squareds minus a negative x squared. That'll work out to be addition. All right, and -3x squared plus 1x squared makes -2x squareds here. And again, bring down the next term and repeat the process. So plus 0x's comes down. And then we think to ourselves, the very first term, the x up here, multiplied by what gives us -2x squared. And that's going to go up top. -2x multiplied by x is going to give us this -2x squareds. Again, don't forget it gets distributed to both of these. So -2x times -1 makes positive 2x. Subtract down. The first one works out just fine. The x squareds go away. But then be mindful we have 0x's minus 2x's. That negative gets distributed is going to give us -2x's. And one more time, bring down the next digit. The next term, I should say, plus 1 comes down. Repeat the process one last time here. Think to ourselves, x out in front, multiplied by what gives us negative 2x. Hopefully we're thinking to ourselves, x times negative 2 makes negative 2x. Distribute, so negative 1 times negative 2 makes positive 2. Subtract down one last time here. The x to the first powers go away. We plan that part out. But then we have 1 minus positive 2. Leaves us with negative 1. That's what we refer to as the remainder. And then up top, we refer to this as the quotient. Now, one way sometimes we write our solution, the overall solution, is we take the quotient, and then we're going to add to that the remainder, negative 1, over the divisor. So the divisor, we divided by x minus 1 out in front there. So that's one way to express our solution sometimes. All right, next, let's try what I consider to be a little bit simpler way to do this, synthetic division. So synthetic division relies on one very important thing. You're dividing by something very special. We're dividing by a term that is 1x to the first power, plus a number or minus a number. All right, so that is a good indication that we can use synthetic division on this one. Doesn't really matter what that first polynomial was, only that we're dividing by a polynomial that is 1x to the first power, either plus a number or minus a number. So getting started with this, what I'm going to do is let's set it up first. So I'm going to draw this symbol, this shape, and then what I'm going to do is basically steal our coefficients over here. All right, in the dividend, we have 1 is our leading coefficient. Now we skipped over the x to the third power. So I need to put a 0 as a placeholder there. Negative 3 is the coefficient on our x squared. We skipped over the x to the first power, so 0 goes there. And then our constant is a 1 is going to go at the end here. I'm going to leave a row empty. Draw a nice horizontal line going across here. Next, let's go ahead and look at this. We're dividing by x minus 1. So what I like to think to myself is, what would I have to replace x with to make this equal 0? So in this case, positive 1 minus 1 makes 0. So we're going to put a positive 1 out in front. Now our process for this synthetic division is you're always going to multiply and then add. So the multiplying is always multiplying by that number we put out in front, that red 1. But first, we go ahead and bring this very first digit down. So 1 comes down. And now we can start our multiply, add, multiply, add. So we take the 1, the red 1 out in front, multiply it by the blue 1 at the bottom. 1 times 1 makes 1. Now we're on to the add step. So we add vertically. So we have 0 plus 1 makes 1. Back to multiply. 1 on the outside, 1 at the bottom in black. 1 times 1 makes 1. Now we add vertically. Negative 3 plus 1 makes negative 2. Multiply. 1 times negative 2 makes negative 2. Add. 0 plus negative 2 makes negative 2. Multiply. Red 1 times negative 2 at the bottom makes negative 2. And then add vertically. 1 plus negative 2 makes negative 1. Now, how do we read all of this? All right, we're done with the process. It's done, but let's see if we can read our solution and make sense of this. All right, the first thing to note is this very last digit here. This is the remainder. The rest of all of this, these are going to be the coefficients for our quotient. All right, so how you read that is that last negative 2, the value right next to the remainder is going to be a constant, and then it's going to be x to the first power, x to the second power, x to the third power with those appropriate coefficients. So overall here we have 1x to the third power plus positive 1x to the second power minus 2x to the first powers minus 2. And hopefully you noticed we got the exact same quotient that we did with long division. We got the exact same remainder. I'll scroll down here to the bottom. as we did with long division as well. So synthetic division can speed this process up, I think, significantly for most students with a little bit of practice, but we're all pretty good at this point with multiplying and adding overall. So hopefully it makes life a little bit easier. Of course, you could still rewrite this just like we did with the long division by taking our quotient and adding the remainder divided by the divisor. So I hope this helps out. Good luck. Make sure that when you're using synthetic division, it only works when you're dividing by 1x to the first power plus a number or minus a number.